a real shame, but yeah, it's looked really good. So I'm going to be talking about hacking your own mobile app. Obviously your own, I'm not talking about hacking anybody else's. Although there are bug bounty programs that make that legitimate, but yeah, I think enough of that. For those who don't know me, my name's Alec Tucker. I head up mobile app development at White Clark Group in North Sydney, and I run the North Sydney-based Xamarin users group, or the Sydney Mobile.net developers group, which trips off the tongue much more nicely. If you see anything here that piques your interest, or you want to find out a bit more about mobile or Xamarin specifically, then by all means come along to that. I've got the URL on the last slide as a bit of a plug. But today, after I've remembered to start my timer, here's what we're going to be looking at. So I'll start with a couple of common myths when it comes to mobile security and reasons that people are often a bit more relaxed about it all than would be ideal. Then we'll go through some common risks, things that are perceived to happen, things looking specifically at the OWASP top 10 and focusing on a couple of those. Then we'll have some example hacks, which of course will go perfectly smoothly and nothing will go wrong. And for each of those, I'll look at some mitigation strategies and how you can protect your apps against that kind of attack. Just out of interest, how many people in here consider themselves mobile devs, specifically mobile devs already? Web devs? Okay, all right, so a lot of the OWASP stuff will be familiar to you at least. So in terms of common myths specific to mobile, one of them is, and this is looking mostly at iOS, one of them is, well, when I submit an app to the App Store, Apple reviews it, and surely they're only going to let it in if it's secure. They must check for security vulnerabilities as part of that. I'll come back in a second to whether or not they do, but I've got friends who've submitted apps to the App Store, and one of them, as an example, the third time he submitted it, the third update, it got rejected for a UI element looking wrong, and the UI element hadn't changed since the first iteration, the first release. And when he released it a fourth time with no UI changes, it went through. So even if they were checking for security vulnerabilities, I wouldn't be recommending that you trusted that. But when it comes to looking at what those vulnerabilities might be, if you think one of them might be data that you've got stored on the device, if it's not sensitive, maybe you don't want to encrypt it, maybe you don't need to encrypt it. Apple, when they look at it, the review team, when they look at it, have got no way of telling whether or not that data is sensitive, whether it should be encrypted, whether it's fine that it's not. So they can't really go and make a judgment call on that for you. The next one is, okay, that's fair enough, but when my app gets deployed through the App Store and it gets installed onto a device, it's encrypted, right? Which means it's protected. Well, yes, it's encrypted. We'll come back to how protected that is in a moment. But you can kind of think of it as, if you wanted to secure your house and you built a 10-foot wall all around it, the average person couldn't get over the wall without some kind of tool. But it's not difficult to get hold of the tools that you need to do that. So encrypting them is significantly better than nothing, but how big an obstacle is it if someone actually wants to get in? I'll come back as well a little later to the general assumption that the operating system handles the security for you. Now, that's more of a trap that iOS devs fall into than it is a trap that Android devs fall into. They kind of know what they're in for on the Android side. So, common risks. I'm basically looking at the OWASP Top 10 for Mobile 2016 here. And the reason I say 2016 is, first of all, I presume most of you, if not all of you, are familiar with the OWASP project, if you're all web devs. Just researching and finding, getting feedback on the most prevalent security weak points. So there's a list for 2014. I'll pop this back up again in a second. There's also a release candidate list for 2016, which has been updated and improved. I'm just going to spend a moment or two running through these and how they kind of morph on to each other. I did give a presentation on this back in April, which is online. If you want more on this, then give me a shout afterwards. But just running through the 2014 list on the left, that first one right up at the top is weak server-side controls. That basically meant weaknesses in the web API that your app is interacting with, not specifically weaknesses on the device or in the app itself. So that has now disappeared from the 2016 list. If we look at insecure data storage, that just comes across fairly straightforward. There is a slight change we'll see in a second. It looks like very nice and easy mapping so far. Unintended data leakage now gets lumped in with insecure data storage. That would typically be, well, any way in which your app leaks data, including the tasks which are taking a screenshot. Poor authentication and authorization, they each get their own item now. A lot of the rest are fairly self-explanatory. Client-side injection becomes code tampering. That's one of the ones that we'll dig into in a few moments' time. Security decisions via untrusted inputs. Somebody reworded that well and just called it client code quality. Improper session handling becomes part of insecure authentication. And lack of binary protection is reverse engineering, and I'll touch on that as well. That leaves two brand new ones in the 2016 list: improper platform usage and extraneous functionality. Improper platform usage is referring to basically whichever platform you're developing for, be it iOS, Android, or Windows 10, they will each have recommendations for how you should do certain things. For example, iOS says if you've got a small amount of sensitive data, it should go in the keychain. If you don't put it there, you're potentially breaching M1. Now, you may have valid reasons for not wanting to do that. You might be thinking, okay, well, I can get into the keychain if I try hard enough. I need to encrypt it myself and then put it in there, which is a perfectly valid approach. Extraneous functionality is referring to, one example, I guess, is putting code in that should never have actually made it all the way out to production. I've got an example of that a bit later. But that would typically be things like you've put some nice authentication into your app, and it's all nicely tied up with certificates talking to your production server, and then a dev has to work on it in the dev environment and then push it through a test environment, and there's all sorts of hoops to jump through to make that work nicely. So they go into the code and just disable that little bit of security checking, and then forget to put it back, and it makes it all the way out into the wild. Now, fairly hot off the press, as of last month, there has been now some formal feedback on that release candidate list for 2016. So I tend to work to 2016, but if you've got security policies, they'll probably refer to the currently active one, which is the 2014 list. So far, the response to the 2016 list has been, do you like what you see? Overwhelmingly yes. Is it an improvement? Overwhelmingly yes. And do you agree with the ordering of the top 10? And again, overwhelmingly yes. It's not quite unanimous, so there may be some tweaks and reordering to the list before it becomes the final list and we lose that RC off it. So if we've got, if we've done this analysis, or if the OWASP Foundation have done this analysis for us, why do common breaches still occur? If we know what's most likely to occur, why doesn't everybody protect against it? And it's the same on the website. In fact, there's a company called ArcSan wrote a report called State of Application Security 2016 Financial Services Report. They looked at a whole host of apps in the finance sector, and they found that 92% were not addressing at least 2 of the top 10. So it's a sector where you'd expect them to be really over the top. Now, yeah, we can talk about which 2 they were and how critical it actually was based on the results. But yeah, it's not what you'd expect. There's also an institution called the Ponemon Institute who did a report called The State of Mobile Application Security back in February 2015, so a little bit long in the tooth now, but it'll probably strike a chord. So one of them is rush to release. You've got some great secure coding standards. All devs absolutely love coding standards and never put up any resistance against them. But then suddenly there's an impending deadline and somebody makes a call, you don't have time, we've actually got to meet the deadline and we can fix this problem later. Does happen. Is it ideal? I'll move on. Insufficient testing, the cause of so many problems, nothing to do with my coding, just insufficient testing. Malware-infected apps and devices. A good example of that is companies with multiple in-house apps that they roll out to all their employees. They have bring your own device policy, so employees can take whatever they like. And someone or a few of them might decide that they actually like having a jailbroken phone and they want to try and put your company's apps onto a jailbroken phone. Yeah, you can get many breaches as a result of that. Low security budget for mobile apps specifically. There's still a little bit of an issue of price point perception. It's a small device, it should be a small number. Lack of specific expertise and lack of security policies for, and this is kind of specific to enterprises. The OWASP documents add a couple more reasons to that. One, as we've mentioned, is the assumption that the operating system is going to cover all the security requirements, which still does happen. And then weaknesses due to cross-platform development and compilation. Now, that last one struck a chord with me because I make a lot of use of Xamarin and love the fact that I can use that to write a proper native app and roll it out to multiple platforms. So I saw that and thought, what are they talking about there? What weaknesses am I falling prey to? A bit of digging showed this is due to that M1 at the top of the 2016 list, which is improper platform usage. The easier it is to write an app and deploy it to a platform without lots of knowledge of that platform, the more likely it is that you're not going to be doing something the way that you really should be on that platform. So that's all that's pointing to, rather than any specific weaknesses in cross-platform development tools. It's just that approach. And to have a secure app on a specific platform, you've got to know about the security capabilities, the security requirements of that platform and how you should be doing things. And there will be slight differences between the platforms. So let's get cracking. So I've got here a couple of things. How many people have iPhones? Anybody got a jailbroken one? Okay, that's what this is. So there's a number of ways to jailbreak these days. You can do it straight from the device with no PC involvement. I used my Mac to do it because it was sitting there, so I thought I may as well. I can tell it's jailbroken straight away because it's got Cydia on it. Oops. So I installed Cydia and went through the jailbreaking process. And now the result is the jailbroken phone. So what can I do now that it's jailbroken? Well, basically, this is a Unix box now. I can SSH into it, start digging around. There's a couple of things I've got to do to be able to do that. So, oh, brilliant, you can't see the tabs down at the bottom. Okay, no, you can, but I've got to drag it down again, otherwise I can't move it. So I'm going to tap one of those and have a look at the apps that I've got installed. So I've added 2 since jailbreaking. The first one is OpenSSH. So you can go through various repositories from within Cydia and install apps that way. So I've put OpenSSH on, which means if I run up a terminal window and drag that across, I'm just going to go to my network settings on the phone, have a look at my IP address, which is there. And now I can go SSH root at 192.168.37. And now it needs a password. Does anyone know what the password is? No. It's not that much of a trade secret. If you go to Google and type iOS root password, it will offer it as an auto-suggestion before you even search. So I'm not actually giving much away when I say it's Alpine, and has been for a long time. So I'm now in my phone here. So if I go, whoops, up to the top, I can just look around the same as I would any Unix box. If I go into the applications folder, I can have a look at all the applications that are on here. Now these are all .app files, so I can grab one of those, put it onto the Mac, and start digging around inside it. Except I can't because of that 10-foot wall that's around each one. Each one of those is encrypted. So we're just going to nip down to, oops, can't click that. We're going to nip down to Bunnings and buy a ladder. Another app that I've installed is called Clutch. And I'll explain what that does in a moment. The first thing I'll just show you is file system content. Shows us where on the phone this sits. So if I come now over here, clean that up, and bin, and have a look at that, I can see Clutch 2. What I can do with that is run it with that switch, and it will show me all the iTunes installed apps that I have, which is basically all the ones that are encrypted. Now the way that Clutch works is, well, first of all, to run an application on the phone, yes, the binary is encrypted. The first thing iOS has to do is decrypt it and then run it. So Clutch will kick off that process. It'll get the operating system to decrypt it. It'll then put the brakes on and dump that decrypted app into an IPA file on the device. So to do that, I would just type clutch to -d for dump, and I can now just put the number in that list. So if I did 15 for my BBC News app, then that would go away and decrypt it. I'm not going to do that because it's not my app. But that's what I would do if I was trying to do that to my own app here. What I can show you is, the next step, and I've had some fun connectivity issues with this, so it's not quite doing what I'd like it to, including disappearing off the screen. There we go. So this is, CyberDuck is just a way to get a nice graphical UI over this, so I can go in, I can browse the file system. I differ a little bit from the hacker stereotype here, where although command line is great, if I can do it with pictures, I'll do it with pictures. So normally this would give you, if it's all connected up, will give you a list. You can navigate your way around, find a file on here, and just drag it to your desktop. So that's what you do to get the IPA file that Clutch has created for you that contains the decrypted app. And to show you what that would look like, there it is. So that is an IPA file. Does anyone know what an IPA file actually is? Yeah, it's one of the many, many file types that is just a zip file. So if you come in here, just rename it to a zip. Yes, I'm sure. Then I can double click and take a look inside. In there you'll find iTunes artwork, maybe some other resource files, and you'll find a payload folder. And in there will be the app. So that's the decrypted binary. Now I'm going to go take a look in one of those, but not that specific one, and I'll show you why. But just to recap those steps so far, it was jailbroken phone, open SSH on the phone, SSH into it, Clutch installed on the phone to decrypt the app, CyberDuck or your tool of choice or command line to get that IPA file off the device onto the Mac, rename it, take a look inside it, and then start digging around. Let me make this a bit smaller, it's really going to be too big. So what I've got here is, yeah, that's way too big. I've got Xamarin Studio with just a very, very basic iOS app. So I've not done it as cross-platform, I've only done an iOS app out of this. So I'm looking in a app delegate CS at the finish launching method. If anyone's from Objective-C land, finish launching is the equivalent of did finish launching with options, and is one of the things that gets called as your app launches. So you can see here, a brilliant example of something that you should never do. User ID and password hard-coded in the app. Great during a security talk. That's just to demonstrate that I'm calling a routine there called isAuthorized. I'm passing in the user ID and password, and that's just some effective framework code. If you are authorized, then presumably it's going to set things up and launch the app. If you're not authorized, it might say get out. It might fail quietly, but just not give you certain options in the app, and I'll talk a bit more about that in a moment. But the main point here is I've got a routine called isAuthorized that returns a bool. It's not uncommon to do something like that. The observant among you will notice that that's always going to return false and would never let me in because it's the wrong password. Now, I compiled this before I came, so if I go and do reveal in Finder and drag that across, I can have a look in bin, iPhone, debug, and there's my binary produced from that code. Okay, let me minimize a few things now so we've got some space. Because what I want to do now is launch, where's it gone? Disassembler called Hopper. I can try and make it fit on that screen. So I just got a demo version installed. Let's take a look at this. So if I drag that binary into here, it'll give me a couple of prompts. Say, how should I disassemble it? Yeah, that's fine. And off it goes. So now, let's see if I can do this. There we go. Anyone good at following assembler? No, me neither. I really wish I hadn't maximized it now. Okay, well, I'll show you the first bit and then I'll solve that problem. So I happen to know that there's a routine called isAuthorized, spelt like that, almost. isAuthorized. And it finds it straight away. So I can see that it is. Let me get rid of this. It's in the app delegate of demo 3, and it takes 2 string parameters. So that's what we're looking for. Now I can tell exactly what it's doing from all of that. Honest, not at all. Okay, now I'm probably going to have to unplug this screen so I can unmaximize it, and then I'll plug that back in again. Hopefully that doesn't mess things up too much with the recording. Any second now. Okay, got it. and back we are. Okay, so we've got is authorized and the corresponding assembler. What I can do is come and click this to get some pseudocode. And that will have a bit of a go at turning that assembler into code for me, which is so much clearer. The critical thing here is right at the bottom. Right at the bottom. Okay, you're going to have to look as it comes up and disappears again. It says, okay, you've got R0 equals R0. Below that, it just says return R0. There you go. Did you see it? So even if we can't figure out exactly what this is doing, we can see that it is returning a value. I'm trying to get hold of this. Okay, there we go. Told you. There you go. So that is returning something back from is authorized. Now, if I can tell from the wording that that's probably going to return true if it's authorized, I can come and fiddle with this. I can make this always return true regardless of what code came before it. I can then save this back into the binary. I can repackage that, and I can install it onto my device so that when it's running, when the binary is running on my device, is authorized is always going to return true, and it's always going to let me in. So if I can do that to my own app, then somebody else can, and that's not a great scenario. So that's basically, I don't know if anyone did have a jailbroken phone and you've got some games on there, for example, that give you infinite lives. Someone's found something like this, modified the binary, and that's how you got hold of it. Okay, let's jump back to the presentation. Let me kill that. Perfect. So that was a jailbroken device with Cydia installed, OpenSSH installed to get into it, Clutch to decrypt the app, Cyberduck to get the IPA off onto the Mac, Hopper to disassemble it. Those were all free with the exception of Hopper, which was a trial version. I think Cyberduck might have been a trial version as well, actually. So that's all well and good. Nice to look at that. Nice to see that it can be done. How can you protect your app against that? How can you stop other people doing that? Well, there are some things that you can do. One of them is this. Can you guys read that? I'll make sure the slides are available afterwards. Basically, that's a bit of code. It's a private bool method called isJailbroken. It's going to return true if the device is jailbroken, false if it's not. All it's doing is calling canopenURL, which will return true if that succeeds, and it's trying to open something with the Cydia prefix. So if the Cydia substrate is installed, that will succeed. If it's not, then it won't. So it's relying on that being the only method of jailbreak detection that you need, which may or may not be the case. And that will, so if I put that into that app and try to run it up on this phone, it would fail. That would return false, which is great. What that won't do is stop Clutch from decrypting it. Won't stop me copying that decrypted IPA file across to the Mac, putting it into Hopper. Won't stop me searching for jailbreak or jailbroken, finding that method, changing it so it always returns false, and getting it to run on my phone. So yes, you can do that, but if you really want to stop it from happening, you've got to build more walls around your house and make them higher and do other things as well. And that becomes an interesting discussion then. You could just change the name. You could call it isn't jailbroken and try and confuse the hacker. You could call it SMH427 and have it return a string that contains a P if it's jailbroken and anything else if it's not. And really what you're trying to do here is just put obstacles in the way of somebody getting in, make it harder for them, slow them down, and make it so that they've really got to be that much more dedicated if they want to get in. And at the end of the day, you kind of accept all you're going to do is slow them down, and you've got to slow them down enough so that it's not worth their while. The other kind of approach that you can take there is to put in redundant process paths into your code. So methods that get called once every 26 times the app is run, or once every 7 times the app is run, or just have it call the app call different methods internally each time it's run and try and make the cycle unpredictable. Have something called is jailbroken and ignore the results. Have something called something completely different and ignore the result except on Tuesdays and Thursdays, or just introduce some kind of random element into that. Because the ideal is if someone's managed to hack your app and get it to run on a jailbroken phone, they'll feel really pleased with themselves. They get up the next morning, try again, and it doesn't work. They're back to square one. You also want to make sure that anything that you're doing, the ideal is that is different with each build. So if somebody managed to hack one version of the app, that hack is useless as soon as you issue an update. There are some software tools that you can use to do this. That list is by no means exhaustive. I didn't even get as far as C. There's a bit of a discussion on the Xamarin forums about using Babel on Xamarin code. There's a lot of different approaches you can take to that. And that's more, you refer to code hardening, which is more than code obfuscation. It's adding in these redundant process paths, adding in those random elements. If we were to talk about just calling that method something different, something obscure, that puts a bit of an obstacle in the way. But as soon as you start taking that route, you're then in danger of ignoring all those nice coding standards that you've got that gives you a nice low cost of ownership of your code, and all your developers know how to find their way around, and it's obvious what's happening from the sensible names of methods and variables, which the hackers are relying on. So depending on your setup, it might be the preferred approach to use a third-party tool to come in and perform some obfuscation on your code during the compilation process, as part of your continuous integration. Certainly if what you're working on is a game or an app that's generating significant revenue, or if you're especially if you're in an enterprise setting, whatever you're doing to protect against this has got to be repeatable and it's got to be auditable. As an organization, you might need to pass various types of audits. You might need to show you're PCI compliant if you're handling personally identifiable information. That there's a whole number of issues that you need to make sure you've got covered there. And as I said, ideally part of your continuous integration, and ideally doing something different with each build without you as a developer doing anything different. Okay, the other hack that we were going to have a look at is looking at insecure communication. So what I want to bring up to do this is, find the icon. So on iOS, I'm using some software called Charles. If you're on a PC, use Fiddler or something equivalent. It's just a web debugging proxy. Again, it's this is something that you do pay for, but I'm on a trial version, so I've just been chatting while I have to wait 10 seconds for it to start. So I'll walk through what you would do with this. So the idea is I'd want to get all internet traffic from my phone being routed through this. Now, the phone doesn't have to be jailbroken to do this. So what we need to do is make sure that the PC that I'm running this on and the phone are on the same network. So I've got that set up here. So if I show the phone, okay, I've lost my phone window. Oh, here we go. So all I was going to do there was show you what we looked at earlier. We just need to get hold of the IP address of the phone, and then same for the PC. So then on the phone, sorry, I was already there. I'd come into here, and I come down to this section at the bottom, HTTP proxy, tap on manual, and in here I'll put the IP address of the PC that I'm running on, and I'd put the Charles default port that it uses, which is 8888. Once I've got that in place, then all traffic from the phone is going to be routed via this web proxy, and I can take a look at it, I can intercept it, I can redirect it, I can send different responses back, which is all well and good, but what if the app's written by someone who knows a thing or two about security and it's all over HTTPS? Well, then we have to spend a little bit more time preparing things. I'm finding my pointer. There it is. Okay, this is one of the nice things about the Mac. The menus appear at the top of the screen, which we can't see. So some of the options that we get in Charles is, first of all, there's a help option. So under help and SSL proxying, which you'll have to take my word is what I'm pressing, there's an option called Charles Root Certificate Help, which gives you a whole set of instructions how you set this up. Basically, there's a second option called Install Charles Root Certificate, which opens up a keychain and puts the certificate there for me. I can then go into that, and if I want to, I can have a look at the trust and change the level of trust that that has on my machine. Once that's done, the next step, I come back into Charles and click another one of these invisible menu options. I've got Install Charles Root Certificate on a mobile device or remote browser. There is also a separate option for that walks you through how to set this up in an iOS simulator. So when I choose Install it in a remote browser, that's what I get. I've got to make sure that I've set the proxy on the phone, which you saw me do, port 8888, and then from the phone, it wants me to go to charlesproxy.com/getSSL. So let's do that quickly. Anyone would think I've been there before. Get SSL. There we go, and I've already got it. If I didn't already have it, that walks me through the process of installing that certificate on this phone. So what that means is if I then go back into the app, I can now intercept that secure traffic, and I can take a look at it decrypted within Charles on the Mac. So again, great that we can look at how to do that, great that we know how to do it. How do we prevent other people doing it in our apps? So let's just get these out of the way and come back to the presentation. So yeah, just a summary, all we really used for that was Charles. All you'd use for it on a Windows machine would be Fiddler or an equivalent. Now again, we've got some code that is, I can make that bigger. There we go. So this, again, the code that I'm showing is all in Xamarin. So this is .NET code. So I'm putting in a server certificate validation callback into my app. So whenever a secure request is made, there's a whole host of SSL responses that can come back. And this is where, if you're in a browser, on the desktop or on a phone, if the certificate's expired, the dates don't match, or it's not yet valid, or it's not issued by an authority you've chosen to trust, there's a whole host of different nuances of reasons why you might not trust it. And the browser will present those to the user and say, this is the story, do you want to carry on? Recommend that you probably don't, is what it normally says. if you're calling that from within an app and you're not doing this, then any one of those failure reasons will just cause the comms to fail, and you won't get through. If you want to give your user any kind of choice in the matter, this is how you'd intercept it. And this passes in the certificates, the chain, and the SSL policy errors. So you can then interrogate the SSL policy errors. And if you want to there, you can say, is this something critical? We definitely don't want to continue. Is it something that might be okay? We want to give the user the choice. That's where you'd put that code in an app. What this code is doing is saying, first of all, check that SSL policy errors contains none. It's not going to let any errors through at all. But that's not enough. It's going to go on and take a look at the certificate that was passed into this. It's calling getCert hash string on the certificate to get the hash of that certificate. This code is assuming that at some point elsewhere in the app you've built up a list called valid certificates, and you've put in there any certificate hashes that are acceptable. So if no errors occurred and it gets the certificate hash and confirms it's in this list of acceptable certificates, then you'll get through. If either of those fail, then you won't. So that's generally referred to as certificate pinning. If you're doing something like this, this is where you have to be careful not to breach M10 extraneous functionality. This is something that will cause you a headache if you're communicating with a dev environment or a UAT environment or system test environment or whatever. So this is what's the phrase I'm looking for? A common point of failure. If someone comes in and says, okay, I'm going to comment that out, just say return true, and I'm sure I'll remember to put it back in when we do the production build. In fact, I think I've seen a talk that Troy had given on, not specifically on apps, but going back a while now, where he was doing some testing, just went to check that a website wasn't falling foul of this, to show it as an example of how to do it, and found out that exactly this had happened. Contacted them, and they said, okay, we'll fix it quick. Okay, so that's the two hacking methods that I wanted to go through. I did want to bring this up as well. So this is again from Arxan. This is from the report that I mentioned earlier. And they looked at the items in that OWASP top 10 list that were most frequently breached. The report's from I think it's from early 2016, I think I'm right in saying. But it's based on the 2014 list because that was the prevailing one at the time, because the newer one's still officially a release candidate. So if you remember those ones that are really high up, M3 is still M3 in the 2016 list. That's insecure communication. So that's things like, or things that would include a man-in-the-middle attack that we just looked at. M10, that massive one on the right, has become M9 in the 2016 list. That's reverse engineering or decompiling. Going back to that first example where we decrypted the binary, brought that onto the Mac and threw it into a disassembler to start having a look around. If you've got a decompiler, that's the point at which you can put that in. It does get interesting looking at Xamarin specifically, which is what I focus on. If you look at an iOS app, just as an example, you can look at an iOS app and find it difficult to get in, or maybe there's barriers, things have been done to make it difficult for you to get into that. If it's done as a cross-platform app, then you can go look at the Android app. And if it's written well as a cross-platform app, it's sharing 90% of its code. So you can go and have a look and get into the Android app and decompile that and see all the code. Then you know what you're searching for in the iOS version. So these are all things that you do have to consider if you're writing apps that do cross all those platforms. I'm not suggesting for a second that you shouldn't share code because it's one of the main benefits, but it is something to just be aware of. Oh yes, it was 2016. So here's my plug for the group in North Sydney. We meet on the second Tuesday of each month, so we're meeting Tuesday next week, and we've got a speaker from Holland who's a very active contributor to the MVVM Cross project used with Xamarin, so he's coming to tell us all about that. There's also a number of Xamarin Dev Days coming up. I haven't put the dates there. Grab me later or look out for Michael Ridland if any of you saw his talk earlier today. He's organising those. So the Sydney one, I think, is on the, when is that? Saturday the 20th, I think. The Brisbane one is, I think, the 3rd of September. The Melbourne one, I'd have to check with Michael. I can't remember. But you'll find all the details up on xamarin.com/devdays if you want to do that. And then final plug. Again, speaking of Michael, so I've been working on this for a long time now, and now Michael's on board. I actually stand a chance of getting it finished. So Michael wrote Fresh MVVM, which is a really good MVVM framework that's getting a lot of traction in the Xamarin world. So he's picking up about half of this book. I've also got contributions coming in from Glenn Stevens, who is a Xamarin University trainer, and Mitchell Tilbrook, who's a lead Android dev at Seatfrog here in Sydney, who I think has given his lightning talk already, or if not, then it's still to come. That's it for me. I'll be hanging around for a short while after this, and then I'll probably be at the event this evening if anyone has any questions. But if you want to shout out any questions now, I'll give it a try. Anyone seen this kind of stuff before?
Actually, certificate bidding is something we're going to be moving to very shortly.
Okay.
Exactly what you said. Switch between dev mode and production. Have you got any suggestions for good mnemonics and processes that we can avoid that?
I think the ideal for that, and probably the only way you can put guarantees around not making that mistake, is to have your builds all going through continuous integration, nicely scripted, so that you kick off a dev build that puts in your pre-compiler options. And you kick off a production build, and you know which build you've kicked off, and you don't actually have to go and fiddle around with anything. I've seen code that is really nicely organized with pre-compilers to handle all that for you, but if you don't have automation around when those are used and when they're not, you'll still miss something. Yep. Okay. Yeah, fair point, thanks. Yep.
Do you know of any ways to keep the private keys secret? Like the start of the app, if you needed some private key for signing, do they go into keychain, but can it be tied to the app store in some way?
It does get interesting where you store that, and I find that argument, as soon as you start talking about encrypting any data that's on the device, if you're using SQL Cipher or any kind of encryption, you need that key somewhere. You just kind of move the weak point somewhere else. Private keys does get kind of interesting. Probably worth chatting a bit offline. Certainly for the general advice for encryption and using things like SQL Cipher on the device, they'll tend to say, and it's distinct from private keys, sorry, but they'll tend to say you've got to avoid using UUIDs, avoid using any hardware IDs from the device. But you can use those as a portion of the key, but a portion of the key has to be entered by the user, so it's not actually stored anywhere. But yeah, some things you have to find a way to store them. Okay, if there's no more, I say thank you very much, and we'll call it a day.